Let's look at an example of how delta z compares to dz. In particular, if z equals x squared minus xy plus 3y squared, and xy changes from 3, negative 1 to 2.96, negative 0.95, compare the values of delta z and dz. You'll notice that our x coordinates are close together, 3 and 2.96, and our y coordinates are close together, negative 1 and negative 0.95. Now, just to make sure we're on the same page here, delta z is the actual change in the function or output values. dz is the differential that we were just looking at. So delta z is really z2 minus z1. And we're going to compute that by finding f of 2.96, negative 0.95, minus f of 3, negative 1. And I know to subtract f of 3, negative 1 because we're going from 3, negative 1 to 2.96, negative 0.95. So yeah, that tells me the order of subtraction. This is approximated by 14.28 minus 15, and that equals like negative 0.72, right? So that's delta z. dz is the partial of f with respect to x at 3, negative 1 times dx plus the partial of f with respect to y at 3, negative 1 times dy. And this will be fairly straightforward. The partial of f with respect to x is 2x minus y, which means that the partial of f with respect to x evaluated at 3, negative 1 is equal to 7. dx is the difference in the x values. I think I flashed on the wrong thing over here. It's 2.96 minus 3, and so negative 0.04. And I shouldn't have tried to squeeze that in there. Anyway, the partial of f with respect to y is negative x plus 6y, which means that the partial of f with respect to y at 3, negative 1 is equal to negative 9. dy is negative 0.95 minus a negative 1, and so dy is 0.05. Putting this together, dz is equal to 7 times negative 0.04, that's fx times dx, minus 9 times 0.05, and that's, of course, fy times dy. The arithmetic on this is that this is negative 0.73. We were to compare the two. Delta z is negative 0.072, dz is negative 0.73. They're pretty close as expected.